Good morning, everyone. Can everyone hear me? Thanks for coming out. It was a good turnout. I know it's been a long couple of days, but I appreciate your time. My name is Esteban Herrera. I'm a program manager working on the diagnostics tools and specifically profiling tools in Visual Studio. And today we're going to take a look at how you can use those tools to profile your ASP.NET applications. Now, I'm going to ask you guys to think back to the last time you got a flat tire. Now, if you're anything like me, while you've changed tires and you know how to do it, it's not until you have that forcing function of getting a flat that you actually took the time to look in your car where the spare was stored. It's not always in the trunk, as I recently learned, where the jack was, and how to put together all these tools. It's not hard per se, but it's not until you have that forcing function that you actually take the time to learn that stuff. And when you're on the shoulder of a busy road, or your application's on fire, it's not always the best time to be learning all that stuff. So if there's one thing that I've learned in my time working in this space, it's that developers using performance profiling tools tend to fall into one of two buckets. They're either people who just got a flat tire and are scrambling to find where the tools are, how they work, how to understand all this data, or there's people whose job it is to be changing tires and to care about performance. Now, chances are that we all fall more in this bucket. I know I certainly did when I started working in this space. So before we jump into a demo to show you where those tools are, I want to briefly talk about why you would use profiling tools. And it's a pretty straightforward set of reasons, right? Profiling tools are great for when your program isn't broken, it's just slow. When it's broken, it's great because you know in what way it broke, so you have a string to pull to go investigate this issue. But when you get an email or a phone call that says, hey, it's running slow, go figure it out, you need a bigger set of data to go start that exploration. And a lot of issues don't arise until you're in production. That's because it's hard to simulate real world load, even with the best tools, and it's really hard to predict human behavior. So users will always find a way to surprise you in how they're using your product. There's a couple great examples from a great Reddit called You're Doing It Wrong, of people using products wrong. So with that being said, let's jump into a demo. So what I have running here is a simple, oh, you guys should probably want to see it, right? It's a simple ASP.NET Core application that just manages a movie library. You can do simple CRUD operations on it. You can add new movies, edit movies, delete them, etc. And you can get errors. Now let's say that I gave this software to a library and I just got a phone call saying that they're running into an issue. They just got a huge donation of movies. They're trying to upload them into the system and they're noticing that their application is running slower and slower. And so let's go investigate that issue. Now, whenever I have dealt with this type of app, my tendency is to blame the database for any performance issues. So I'm going to start by exploring whatever information I can get about the database. And to start the investigation, I can hit Alt F2 to bring up this page, or go to the debug menu and click on Performance Profiler right there, and you'll get this page that gives you a couple options of what tools you can run against the application that you have open right now. In this case, we're going to pick the database tool, and you'll notice that a couple of the tools got grayed out. Now, we wrote these tools to run cooperatively, so you're able to run several of them next to each other and collect a bunch of different information at the same time. However, some of them have significant overhead, and so we try to guide your choices by showing you what tools you can run together and still get decent performance. But as I'll talk about at the end of the presentation a little bit, there's a way to run every single tool at the same time. But in this case, we're going to run the database tool and the CPU usage tool, which is where I would recommend any of your investigations should start. One other thing I want to note briefly is that before we launch this profiling session, you'll notice that if I'm in debug mode, I get a warning here reminding me to switch to release mode. And that's because to get a realistic trace of your program running, it's important that you are as close as to what it is in production. And so we're just going to launch the profiling session, and this is going to launch whatever target I selected with the tools I selected, and you'll notice right away we're collecting data. Now, for this demo, I wrote a script that just reads a bunch of movies from a file and tries to upload them to the database. So as I trigger that script, we'll notice that there's CPU activity being recorded right there. And after running for a while, I'm going to stop it and then stop the collection of the session. Now, while this wheel is spinning, we're doing a few things, but we're building graphs and tables that will help you explore the data we just collected. We're also saving all this information into a diag session file, which you'll notice we're in a new tab right now. This diag session file can be saved and shared with anybody that has Visual Studio, and they can, well, even if they don't have Visual Studio, but if they have Visual Studio, they can open it and see the same information that we're looking at. If they have access to symbols, they'll also be able to see the source that generated a lot of this information. So we'll notice right away we get all the database queries that occurred during our trace, and we get this nice graph across the top that will help you notice places that might be of interest to you to investigate. And if I select a region of the graph, our table below will filter to that time selection. So if I select this time in the middle where there's no activity when I was just talking, there are no queries happening there. So it looks like there are, if I look at the beginning, there are 4 queries which account for the entirety of this, of the database activity during this trace. And these are all associated with startup time. And so I'm pretty sure that's not my issue. I would have loved to hand this off to a database expert, but we're going to have to dig deeper into the issue. And to do that, we're going to switch over to the CPU usage graph, or tab. And what we'll see right away is a flat list of all the functions that ran during that time and how much percentage of our time was spent in those functions. This list can be ordered by, or can be ordered by any of these columns. It can be filtered to just be a specific thread. You can hide native code, show external like system code. So this is a great place to start that investigation. And just like the database tool, if I select a region of the graph, that table will be updated to show that information just for that time slice. One thing I want to point out here is there's 2 columns here, one called total CPU time, the other self CPU time, and the difference between those is subtle but important. If I have a function A that takes 10 seconds to execute, but that function calls function B and function C, each of which take 5 seconds each to execute. Function A gets attributed 10 seconds of execution time, but so B and C account for 50% of them each. Function A itself accounted for 0% of that. So if you see a large percentage in the total CPU time, that means that a lot of, this is a roll-up of everything that this function calls in, as a consequence of being called. So the next step from this view would be to find this first function that looks like an interesting place for your application. That, since I know that I am adding movies to the database, this create function call is where I'm going to start. And there's a couple places I can go from here. The first is this caller callee view, which is a great way to navigate what I was talking about, a function calling several other functions. This center frame you'll see shows the current function that we were at during that point in time. And we can see the called functions to the right, and we can see which functions called us on this left. From here, you'll get a percentage, just like what I was talking about earlier, of how much of the time of the current function is attributed to the functions that it called. Now, this sometimes can get you to where you want to be looking at in your code right away, but it can sometimes be complicated to navigate if you have a complex model, multi-threaded application. It can be, or if you're in async, if you have a lot of async stuff going on, that can be difficult to navigate. So another way that you can get to that same information is to actually see the call tree. And what you'll notice is that we get an actual call tree, and we auto-expand the hop path of your application up to a point where we can't expand anymore without really diving into some heuristics. So we think this is a great place to focus your attention to fix this performance issue. Now, in this case, I know that 2 functions above, I'm actually validating every movie that I try to add to my library, and I'm doing that just by calling to a movie database API and just checking that it actually gets a result when I do that. But it looks like I'm trying to be clever here, and I'm caching the movie so that I don't have to validate every single movie. Now, if I go to my source, I can see that I used a linked list to implement that cache, which I remember my data structures professor saying that lookup time in a linked list is an ON function. So this is a really silly way to implement a cache. So to fix that, I can switch to a hash set. Just 1 second. And if I run that same profiling session, we'll notice that we'll see a difference, whereas now 32% of our time in this validate input function is spent in this validate input, is in this section of code, this actual line 42, where you're seeing if the cache is added. That should go down if we run the same session again. So let's see that be true. So same thing, I hit Alt F2, I select my target, and I'm going to run the application. Okay. Looks like we're up and running, and I'm going to hit it with that same script to add a bunch of movies. We'll stop it, stop collecting, and that's kind of the loop that you're going to do if you're doing a deep investigation. There's going to be data that's going to point you to other places, or you're going to make changes that you're going to want to validate by profiling again. So in this case, I'm going to select, I know that this activity at the beginning is associated with startup, so I'm going to select this CPU activity over here, filter to that, and see what the CPU is doing at that point. Now, going to that call tree, we now can see that this validate input now only accounts for 14% of the time of this validate input call. Now, I mentioned that you are able to run these tools concurrently, and you're actually able to run them remotely too. So you don't need to have Visual Studio. I said that a lot of issues don't arise until you're in production, so it makes sense that you would want to collect the data in production. The documentation for the tools that are available is at that link. You guys will have access to these slides afterwards. But to collect remotely, you would use the command line tool that we ship with VS, or you can download with the remote tools. If you're familiar with the remote debugging tools, it's that same set of tools. That's the same download. You'll get this VS Diagnostics XC, and that same loop just happens from the command line. You give your session an ID, you attach to a process by giving it a process ID, and then there's a configuration file that tells it which collector agents you want running to collect CPU data or database data or memory data. And information for that is found at those links too. So yeah, with that being said, I encourage you guys to go try it for yourself. It's very easy to run this tool against your application, and hopefully you'll catch some behavior that maybe you didn't know was there. I encourage you, if for nothing else, that you'll know where these tools are the next time you are investigating a performance issue. Feel free, if you run into any problems or have any questions while you're doing that, to reach out to me and ask any questions. The code that I showed is at the GitHub repo there. And if you want to set up a conversation, whether it's this week or any point in the future, there's a 30-second survey right there to just get your contact information, and we can chat more. So I'll stick around after if there's any questions. Thank you so much for your time. I hope you feel more prepared for your next flat tire. Thank you.